happens when you use Windows, so you're reliable for projectors. Okay, so today I want to talk about Cro. What is Cro? Cro is a set of libraries for the Raku language for building effectively distributed systems, but it turns out most of the distributed systems people want to build are either web APIs or web applications. So probably almost all of its usage is for that. But it also speaks things like LDAP and so forth as well. So there is kind of a little bit like Git. You have plumbing and you have porcelain, and I'm going to really talk about porcelain mostly today. But at the very base of it all is something called Cro Core, which is a way of composing systems that process network requests and so forth out of a set of small components. For example, a HTTP pipeline is a request parser, and then something that's the application, and then something that makes a HTTP response. On top of Cro Core, we have Cro TLS, which is for providing transport layer security using the OpenSSL. On top of that, we finally reached something that you might want to use. This actually has a bunch of plumbing components for HTTP, and then the bits in white are the user space stuff, if you like, and there's a HTTP client, and then there's a HTTP server and the router, and that's largely what I'll talk about today. So this module is actually pretty useful in its own right if what you're building is a HTTP API or a some kind of single page application where what you actually have behind it is really just serving a JavaScript application and then a load of routes that do JSON stuff. On top of that, there is Cro WebSocket, which does WebSockets for interactive-y stuff. And again, there's plumbing, and then there's a client, and then there's a router plugin, so you can very easily receive a request and then say, okay, let's upgrade this to a WebSocket. And finally, on top, there's Cro Web App, which is actually a web framework built on top of the whole thing for when you're doing more server-side applications. And for a while, we were like, no, we're not building web framework, we're not building web framework. And then finally, we are building a web framework. So, fine, okay. So we'll talk about these three bits today. And what is the router? What is this all about? So it's the thing that takes an incoming HTTP request and says, okay, this looks like a HTTP request, what should we do with it? And it decides what bit of logic is going to handle that. And it'll potentially apply a lot of rules before that to decide it. Many things plug into the router as well. So things like WebSocket support, things like templating and web form handling and OpenAPI are all built atop of this. So once you're familiar with the basics of it, then you're ready to move on and add all of these extras according to what you need. So how do we get set up with a Cro application? Because we need one of those before we can play with the router. We can write a little bit of code if we don't like using any kind of tooling. So we use a couple of modules. We then see our first example of the root block there. And this root here is where we define the different routes, that is mappings of incoming requests to code to handle them. And in this case, we're just handling the request to the base URL, just a slash, and just saying return a text plain response that says hello world. Now in Cro, a web application is anything that transforms a HTTP request into a HTTP response. So the router is the most common way of doing that, but technically you could put whatever you wanted on top of it instead. So here we create a server, we tell it which port, we tell it which application, we start it, and then we run it until someone sends it SIG_int. And then we cleanly shut it down and exit. Okay, so that's one way of doing it. We could also use the Cro command line tool, where we say Cro sturb and we give it a name of some little ID for our application. This gives you a slightly better setup because what this actually does is it gives you a a module containing your roots, not just putting them straight in the source file. Of course, you can do that with what I had on the previous slide as well. And that's very nice if you want to unit test your root handlers. Or we can use the comma IDE, and this has a project wizard where you just say, I want to make a Cro web application, and you select which sort of things you want, like I want to use templates, I want to use WebSockets, and it will produce a project for you, and it'll even produce a sample test for you to encourage you to write tests. All right, so let's take a look at how we actually use the router. So first of all, segment matching. So here we can see a few examples. So these are all routes where things are static. So for example, if I do get slash, here I say get. This little arrow here you can read as lambda if that makes you happy. Otherwise, all you need to know is that you're declaring an anonymous piece of code and it's being given to get. This is also the same, except we're saying that we take one argument, but we only accept the argument if it matches the string about. This one down here, it has to match services development, so 2 literal parameters, so it does get slash of that. What if we actually want to get some interesting data into this? Well, we just replace one of those segments with a variable. So that is a normal parameter. In fact, that's what you would most often see after the slash, sorry, the arrow in a pointy block. So one of the things to be aware of is that it actually uses very similar rules, or pretty much identical rules for matching as the Raku regex engine. And it actually uses that to do the routing as well, at least at the first filtering step. That's kind of nice because it means it builds an automaton, and it doesn't have to go through all 100 of your routes. It can eliminate a lot of them very, very quickly. So this is neat. It also means, though, that you get things like this. If I have a root product search, and then I have a product and it takes some ID, if I request product search, it does not matter which order I write these two in. The one with the literal will always win. You can also put types on them. So you can say this has to be an integer, or it has to be an unsigned integer, so positive only, or it has to be something that fits into a 32-bit integer, maybe because that's what we know we should be getting and passing on downwards. Or we can constrain it further. So this is how we make a subset type, where we say it's a type of string, but actually only strings that match this particular pattern. Don't worry much about the pattern, it's just a way of matching a UUID v4. And then we just use it as a type. So if you do a get and you put a valid UUID for v4 there, then this works, and if you don't, then it's a 404. Yep. You can do optional and slurpy as well. So if I have a menu, and then maybe you can look at a section of the menu, then I just stick the question mark on there, and it works for both of these. If I don't know how many pieces of URL I want to take, I just say, take whatever. That's what star normally means in Raku. Whatever. So we say take whatever number of root segments come in. And basically what you've just received is not only a guide to how to match URL segments, but if you haven't done it before, you now understand how to use Raku signatures as well. So I guess that's kind of nice. One of the things to note about this, if you look at this $ID, in a lot of web frameworks and libraries for doing HTTP things, you specify your root, and then you specify the code that receives the arguments. And here, because we use the signature, and then we introspect that and produce the routing table from it, then you only have to say things once. So this is really good if you want to be lazy and not have typos spoiling your day and things like that. Okay, everyone happy so far? Yay. He looks happy. Okay, let's serve static content. That sounds exciting. So, single files. Okay, so you say static, and then you name the file that you want to serve. And it will look at the file extension of this, and it will map it to automatically to a suitable content type as well. It's got a huge directory of those bundled. But what if we want to actually serve some file that is within that directory? So we have, for example, a load of JavaScript files, and we want to serve all of the ones that are in this directory. Yeah, we just do that. We say, jail yourself within this directory, and then look at this file. And if we have multiple path segments, we can do the same. And it actually will very carefully make sure that you don't do directory traversal attacks by doing .. and things like that. So you're safe from those things. If you just want to use Cro partly to serve up a load of static web content, you might also want to specify indexes. So if someone requests just a URL ending in the slash, or that doesn't map to something other than a directory, then we'll serve that particular page by default. And you can also configure additions to the media types or overrides to the media types. So this is generally your way of getting your static things served. But a lot of the responses we want to produce are a little bit more interesting. So I've already showed you that example where we had the we were doing content here, okay? And we're passing a content type, and we were passing something to hand back. This is how content is implemented. This is what the code behind content looks like. So it takes a couple of arguments, the content type, the body. It says, well, if there isn't a response status so far, set it to 200. That's a reasonably okay response. And if we have an encoding, then we want to stick it as the char set on the response type. If not, then just set the content type there. And then we set the body. Now, that just becomes a HTTP header. That's pretty boring. The body goes on a much more interesting journey. Because when we give it a body, it says, okay, I need to figure out how to turn this body into something that I can send over the network as a series of bytes. So it looks and says, what sort of serializers do I have available? And it picks one, and then it uses the one that it's picked in order to serialize it. And these are the ones that you get by default. So you get JSON, you have a binary one, you have text, you have a supply one. And just as an example, this is how we can produce some JSON. So we just say the content type is application JSON. Here's a hash, and we're just that $ID is just short for $ID, $ID. It's a way of making a pair. So this will be served as JSON for us. That's kind of nice. And it does it based on the content type. And if you have a vendor-specific content type that ends in the +JSON suffix, then it will know how to do it for that as well. Now, this one is kind of interesting. What happens here is we provide a supply body. And the supply is something that produces values reactively over time. What we're doing here is we're saying every 1 second, emit a number. And it turns out that if you actually do this, and okay, do you want to give me the 30 seconds I need to sort the demo out? Yay. Oh, I can even keep talking while I do it. Okay, so but I can't type my password while I talk. Otherwise, I type what I'm... No, come... Excellent. Okay, so... Please work. Thank you. Okay, So what do I need in order to do a demo? I, of course, need my IDE because, okay, so let's start this up. And I need a new laptop. It's so slow in my VM. Okay, has it remembered the correct project? Yes, it has. Excellent. And then it's even nicely okay. And then yes, this is the comma IDE, and I can run this project. Enjoy the beautiful syntax highlighting. Okay, and then this is up and running. So, all right, let's make a new tab. Let's, how long does it take to open a new tab? I'm really ordering a new laptop. Okay, let's curl localhost 20,000 / is it called tick? Is it called tick or ticks? Tick? What on earth is this machine doing? No, it was called ticks. I am just cursed today. Okay, wow, look at that. Okay, so this is how you can actually use curl and serve content to it sort of over time. And I actually didn't get around to trying it, but I'm wondering if you can send backspace characters and do all sorts of escape sequences too. That'd be good fun. Okay, so anyway, if you need to do streaming stuff, of course, a more practical reason that you might want to do this is serving an absolutely huge file, but without pulling it all into memory, or if you were producing that file over time and you wanted to serve it out. That would be a good reason to do that. And because the supply model does back pressure and stuff, then this probably will work out pretty well. Okay, what if for some reason we decided that we wanted to send back YAML instead? Well, we can do that. We write a body serializer that looks like this. Okay, so we do the body serializer. We decide when we are applicable. So we say we're applicable when the content type is text/YAML. And then I've just used the YAML-ish serializer here. The ish scares me a bit, but okay. And then we save the YAML. So now I have a bunch of YAML. I turn it into bytes in UTF-8 because that's what I need to send over the network. Content type has to be in bytes, so I need to do that. And then finally, I'm meant to always, the contract for body parsers is they always produce a supply. And if we actually just want to produce a single binary blob, we just write it like that. But this in principle means that you could have a streaming YAML parser and send it straight over the network as it produces stuff. So that's my YAML body serializer. I just say in my root block, please use this body serializer for all of the roots. And then I can just use it by saying text YAML instead. Yep, so that wasn't so bad. Redirects. Okay, there's a redirect routine. We specify where we're going. We can optionally specify whether it's C other or permanent as well, by passing the named arguments there. Error responses. So we have a bunch of helpers for those as well. So here's a nice little advent calendar where we, if you try and look at a day too early, then we tell you you're very naughty and give a 404 back. Okay, so that's how we can do that. There's helpers for a bunch of other errors too. So if you want to just say, oh, it's a bad request, or it's forbidden, or it's a conflict, there's helpers for that. Otherwise, you can just use set status instead and put in the status code. We don't have a built-in for I'm a teapot, for example. Send a pull request. Okay, but what about if you are actually building a web application and you want to render a template? So when I started out doing Cro, I was like, you know, we don't need another template engine because you can just integrate one that already exists in the ecosystem. And after hearing Cro doesn't do templates 20 times, I'm like, you know what happens when you really annoy a compiler developer? They write a compiler. So I made a template language so I could write a compiler for it. So Cro Web App Template is basically a templating engine that feels kind of like Raku. And it has the usual things: conditionals, interpolation, subroutines. It has modules, which is kind of nice because then you can reuse stuff. Automatically escapes data, and even nicer, there's actually IDE support for it as well. So you get syntax highlighting and autocomplete and code navigation of your templates if you're using comma, which is kind of nice. I'll show you it in a moment. So here is an example of a template. And actually, maybe let's just flip over to the IDE, because what on earth have I done here? Brilliant. I think this is the one. Yeah, this is the one. Okay. So you can see here that we have a sub story, and it takes some news story that we're going to render. You can see it does $s.headline. So when you have an opening angle and then you have a sigil, this we call it a sigil tag, and it is some kind of special meaning. So the dollar just means interpolate, and then you can call a method like headline after it. When you have question mark, then there you can actually do a conditional. Here, yeah, you can see the slash question mark to close it. This is a subroutine, and it takes a parameter, so we declared sub, and then we can call it with ampersand here. Okay. And layout is actually a surrounding layout for this. If I just go to my layout here, and let's Control B to go to the thing. There it is. Layout actually takes the body that it gets and sticks it in the middle of this section here as well. So this is reasonably capable. And okay. So, yeah, I didn't mention that one. Okay, there's also the at one, which means iterate this thing and do the thing within it each time as well. Okay, I think the conditional, yeah, the subcall I mentioned. Okay, conditional and so forth. Okay, so how do we use the templates? So we use the Cro Web App Template module. This gives us a router plugin called template. At which point I can say, okay, you find templates in this directory. Then we name the template, and then we pass the data that we want to render. And that's it. So this integrates pretty nicely. In fact, you maybe won't even know it's a plugin. Okay, and this is the page layout that I mentioned. Notice we've stuck the title in there. We're taking arguments and so on. Okay, and then this is how we do a use. And we actually just added support for having template modules that can be distributed on cpan as well. So we're actually working on a Bootstrap one, so you can get easy access to a lot of the Bootstrap stuff and get a nice autocomplete of things in the IDE as well. So, okay, that's templates. Query strings, cookies, and headers. So if root segments are positional parameters, then query string parameters must be named. Yes. Okay, so we just say that colon there, that's a named parameter. This will be populated from the query string. Remember that these are optional by default. You can also put types on them. You can also constrain them. It's kind of smart about its error handling, because if you have a problem with matching root segments, you get a 404. But if you have a problem with not meeting the requirements on the query string things, you get a 400. Bad request. So tries to get HTTP right, so you don't have to think too hard about it. The other thing this means is that you can actually have multiple routes with the same root segments, but then you can do different kinds of query string requirements as well, and actually have different bits of root logic based on that. So they almost work a little bit like multi-subs. If you do the same, but you put is header or is cookie, instead of sourcing the data from the query string, it sources it either from the headers of the HTTP request, for example, getting the user agent, or it sources it from the cookie. The cookies that are sent with the request instead. So this one we can keep track of the last visit you made, for example, and there we can set another cookie. That's how you set a cookie. Request bodies. Okay, so a lot of the time we don't just get given query string parameters or something like that. What we actually get sent is, for example, a form that gets submitted, or somebody posts some JSON to us. So we have a few different ways to get the request body, and these kind of are listed from high level to low level. So the do the right thing way is just to say request body and give it a block that receives the body. This will automatically go and try and figure out what to do with that request body by finding a body parser for it. If you know you just want a string, you say request body text. If you know you just want the bytes, you can say request body blob. And if for some reason you actually want to stream it, for example, you're receiving a very large upload and you want to shove it off the disk very quickly, you can actually get the supply, that is the reactive stream of bytes as they arrive over the network. And yeah, I haven't needed to do that yet for anything, but it's there. So again, we have a body parser selector and a body parser object. These are the built-in ones. The first two are for browsers that submit stuff. So that's just normal forms. This is what we use if we're doing file uploads. There's also JSON. There's then a couple of fallback options. And text fallback is if you have text /, and binary fallback is if nothing else works, just give us a blob of the bytes. So this is how I could get some JSON, provided that the JSON request was sent, I should say. Okay, so it would have to be application JSON. It passes into this this hash for me. But because this is a signature, we can use signatures to take things apart and validate them. So I could instead write this. I could declare a rating subset, which is integers between 1 and 5. And then I can say get the request body, and hopefully it's a hash, and then in it, please find the keys, rating, and comment, stick them into these variables. If the rating is not actually an integer between 1 and 5, or if it's missing, or if there's unexpected extra data in here, it hands back a 400 for you. Okay, so you can actually do validation there. Of course, if you're doing something public-facing, you might want to use OpenAPI instead, so you've got a nice schema to give people. But yeah, this is a way of quickly getting a bit of validation in there. We can also plug in custom body parsers. This is a YAML one. Okay, it says it's applicable if there's a content type, and the content type is text YAML. And then all it needs to do here is return loading the YAML. Now, because the body arrives asynchronously, you get to do various bits of concurrent stuff in here, and you're actually expected to hand back a promise as well. So that's what we're saying here is await the text of the body, then feed it into our JSON provider, and actually do this asynchronously, because you don't want to block up the whole request pipeline on this. We use it by saying body parser, and actually at this point we could submit JSON to this, or we could submit YAML to this, and this code will work just the same whichever one we submit. It doesn't actually really care. And yes, you could write a body parser, a body serializer selector that looks at what was requested and then hands back the same as well, for example. But what if we need to collect data from a form because we're doing a web app? Forms are quite annoying and tedious to do, but we've been working on something to make that less the case called Cro Web App Form. And you actually define the form as a class, and you have a template built in for rendering the form. One thing I'll point out, pretty much everything else that I've shown you so far is stuff that's been in production and doing stuff and occasionally making some money for a while. But this stuff is basically brand new, the form. So this forms thing is probably the least mature of things. This is how it looks. Okay, so we declare a class. We do the Cro Web App Form role. And then we use traits to describe the kind of form we want. So this is a rating. It's required. And it should be between 1 and 5. And please pass it into an integer as well. You can see the name is not required. That's optional. Here we want a multi-line text field with 3 rows and a bunch of columns. We give it a max length. So then we'll write 2 templates. One will be for submitting a review, like this. One will be for thanking people after they have submitted the review. This form thing here is part of the standard library for the templates, so it's just a built-in function. And here are the routes that we write. So when we do a GET request to submit review, we say, here's the template, and the form should just be an empty review. In here, when we get a post of that, we say, please put the form data into here. What form data does is it actually looks at the signature of this and says, what is it expecting? Oh, it wants a review. Oh, okay. Let's try and make one based upon the form data that was submitted from the browser. We can then check if it's valid. If it is, we send the thank you template. If it's not, then we just send back the form again and say, okay, have another go. And because we validated it, it'll automatically have the validation errors in there as well. We also have worked on making this look nice by default, thanks to Bootstrap. So if you import this library using a use, then you can just say BS form, and it does the rendering of the form with all of the Bootstrap classes. And then the form looks kind of nicer than it would if you didn't do that. So that's kind of convenient. Middleware. Okay, so middleware is stuff that happens around the request, or before the request, or after the request. Now, in a way, Cro is almost all middleware because it's a pipeline of components that get assembled. So all we're really doing is sticking something into the pipeline. And we can stick it before we try and match a route. We can stick it before we run a matched route. Okay, so if we didn't find a route handler for it, they'd never run this one, but we would run this one, the before. And after matched and after are the same. You can also install the middleware at the server level instead of inside of your root block. So some example. Here we are serving a load of images, JavaScript, CSS, and we want to have them cached. So we say, after we have matched one of these routes, please stick a cache control header on it. Here's another one. If we get a 404 produced from the router, please render this template, which is a nice not found page. Now, you can write middleware as a block or as a class. There's a bunch of trade-offs for that. Basically, you probably want to do it as a block most of the time. You can actually get some reuse of this by factoring it out into a function as well. However, if you write middleware as a class, you get access directly to the asynchronous pipeline of requests, which means that we can write things like delay monkey very easily. Delay monkey is something that randomly inserts delays into requests. And this is actually a very easy thing to write because the stream of requests is a supply. And if you want to know more about supplies, then come to my talk at last year's workshop. If you here we just say every, say, 10% of requests, pick a number between 1 and 5 and delay the request by that. So whenever 1, 2, 3, 4, or 5 seconds has elapsed, emit the request. If we're lucky, 90% of the time we end up here, we emit the request right away. So if you need to do other stuff where you hook into doing asynchronous things, for example, I had a case where we have some session, we're getting requests coming in, and we want to put a JSON web token on them to send them off to the back end stuff, and that JSON web token is translated from a session cookie into a lookup, which is then the JWT. And because we're doing that asynchronously and as an async call, it was quite convenient to do it in here. I actually once had to do that in Node.js, and it wasn't quite so good fun because the library I used didn't think you would ever want to do asynchronous work when you were adding headers to the request, which was, yeah. So that's how we use delay monkey. Okay, you say before we handle any of the requests, apply a delay to them. That's it. Composing routes. Okay, so it's not very nice if you keep adding routes, and then you have 1,000 lines of route block. And at that point, you start thinking, yeah, this is not really how the world should be. So thankfully, there's ways to factor them out. There's other reasons you might want to do this, or ways you might choose which routes to put in different blocks. You might want different middleware. So we probably want caching on our images and other assets, but we don't want it on everything else. Or we might also want to have everything under a certain prefix, and we don't want to repeat it on every single URL handler. So we can do this. We can have a subroutine. It can return a route block. So here it is for our assets. And then we just say include assets. And it will call the subroutine. It will take the route block that the subroutine returns, and it will add those routes into the route table. So this is flattening inclusion of routes, and that means that all of the routes here are compiled into a single route matcher. And what that actually means for you is you can confidently factor these things out because you know it will compile into pretty much the same matching table, and you're not going to break the way that your rules match. Here is another example. We have a bunch of routes for some blogging system, because everyone writes a blogging system. And then we want to include it, but we want to have it under the prefix /blog /whatever. Okay, so that's how we do that. You can actually include a load of things just by calling include once as well. And you can mix and match. So there's the assets, there's blog mapped to that. If you want to have multiple URL segments, then you need to pass a list of things on the left. Okay, and it will be under, say, /shop /products, and then whatever routes are available. One thing you can't do with include, though, is put after middleware in there. You could do after matched, you can do before matched, but you can't do before and after. And that is because it couldn't possibly know which things to apply the before and after middleware to until it has matched the route. But it can't match the route because before runs before you've matched the route. Does that make any sense at all? I have no idea. Anyway, this will complain if you try it, okay? Because it can't figure out when it should do this because, well, it doesn't actually know if anything in this this block would match. And of course, we don't want to include this and have it sort of splatted over all of the different routes that come from other route blocks that we include. So for this, there is a way of doing it, but instead you want to use delegate. Delegate works differently. because all it does is install a single entry into the root table, which is, in this case, the CMS prefix and everything beneath it. And then it delegates the root to the root block here. And then this root block does its own set of pipeline stuff. So in this case, the before and after middleware can run after we have done the delegation. This means you're sort of doing two sets of routing. It's not so bad, but it adds a little bit of extra overhead. But it's the way you want to do it if you want to have before and after middleware and you want to delegate to it. Another thing to note about delegate is that it actually doesn't just work with the router. So include has to be another root block. With delegate, if somebody wrote a Cro GraphQL thing, you could actually just mount the GraphQL thing there, and it wouldn't actually have to be based on a root block at all. So, yeah, delegate is a double dispatch, okay? And yeah, any Cro transform can be mounted with delegate. So this can be potentially quite useful as well. Okay, we're almost there. Sessions and auth. Okay. So if we want to have a session object, the best thing to do is make it do the Cro auth role, and that gets you a few conveniences. It doesn't have to really be anything to do with auth, but you should stick that role on it so you can get easy router integration of the session. And I'll show you in a moment what I mean. Again, it's just a class. And here we have a number of views. Here we just add an extra one to that view. One of the nice things, if you actually wanted to make this thread safe for multiple concurrent requests, which technically I should, you can use monitors, replace class with monitor, and then you're thread safe, which is kind of nice. So here we have a bit of middleware called in-memory session. And that's what it sounds like. It basically keeps track of all the sessions in memory. There's also a persistent session, and then there's a bunch of modules implementing that on the ecosystem, and that store the session in different kinds of ways. So here, this is just in memory. We parameterize it with the type of the session object. And then when we get a request coming in, if there is no session cookie set, we make a new session. We then make sure the cookie gets set on the response so that we'll get it next time. Otherwise, we just look the session up, and then it expires, and you can configure the expiration time if you want as well. Now, the reason that we put this role here is because it tells the router, this see the example session type here? The router looks at this, and it says, this is actually an auth type. And what I'm going to do is, instead of matching it against the root segment, I'm going to take it from the request as the auth object and populate that instead. What this means is you can just receive your session as a normal parameter. So then we just add to the session, we get the number of views, and include it into the result. Now, this becomes kind of nice. And by the way, it actually just pulled it out of request.auth. This is the property that powers all of this. But this gets kind of nice when we start having authentication and different kinds of roles and different kinds of user. Because we can actually use the type to convey what sort of permissions the user should have. So here is another example. We can carry a username in there. This is how we set up basic authentication. Here is a very secure method of checking that the password is correct. Okay. And again, the role does most of the hard work. Here we specify the type, and we specify what property to instantiate this with the username. Then here, in our root, we say logged in. Now, if we do not supply a correct username and password, the middleware will not populate auth. So, well, there's a few different ways you can do it. In this case, actually, it would not even populate auth, so there wouldn't be a username there. And so at this point, the type check would simply fail, and then you'd get a 401. If, on the other hand, you were doing something where the session carries a logged-in property, you could just write a subset like this. Okay, and you can actually do other subsetty things where you can declare a subset saying, well, it should be a session object carrying a user who is logged in with this role. And then you would just put, you know, admin user or something like that there. And that is how you declare what you need. Last but not least, WebSockets. Time? Yep. I'm out. Yep. Okay. This is the last thing. Okay. So, of course, the demo is a chat app because it always is. Okay. So we'll have a little template. And this is why you should hire me to write Raku, not JavaScript, because I know how to write it without using 10,000 lines of framework, as is fashionable now. So here, we're just going to, I mean, yeah, this isn't very important. All we really have is a form, a text box where we type a message, a send button. When we click send, we send it over the WebSocket. When we receive a message, we'll just append it somewhere. And yeah, apologies for my JavaScript skills. Here is the backend. So we're going to have a supplier, which is basically a way of doing publish subscribe. And we're going to get a request, and we're going to upgrade it using the WebSocket plugin. And this gives us a supply of incoming messages. Then we'll say, whenever we get an incoming message from the WebSocket, and whenever we get its text, send it on this supplier. That is, publish it to everybody. And whenever someone publishes a message, just send it. That's it. Okay, and that is all we have to do to set it up. And let me very, very quickly demo this. Okay, the final demo. Oh wow, that's got up to quite a lot now. At least we know it's stable. Okay, so let's try this. Localhost 2020 chat. No, because that's 30,000. That's 2,000. Guess the port number. Who are you? Who am I? I can be that person. We need somebody else. Who? What name shall we have? Oh, no, come on. When your browser is too clever for you. What shall we? Let's have Dave. There's always someone called Dave. Hello. Oh, look, there it is. There we are. Okay. It works. Okay, so I am well and truly out of time, especially because of the fun at the start of the projector. Sorry about that. So anyway, that's all for today. Yeah, come and find me later if you have questions. And yeah, thanks for listening.